or Spark differentiation. So how the Spark is differentiate with other technologies. So Spark can be defined as a unified engine for processing large scale distributed data on premises of the data center or in cloud. In so on top of in cloud Spark provide unified distribution. The cloud may be Ali Cloud, GCP, Azure, and AWS. Some of the key characteristic and differentiators of a Spark framework is follow: speed. So when we talk about Spark, we talk about speed, usability, modularity. So Spark take advantage of hardware. So it's support multi-threading, multi-processing to execute workload efficiently. Spark create direct acyclic graph, which we call DAG, for computing the query. Graph can be decomposed into tasks that can be executed in parallel across the cluster. The physical execution engine of Spark, known as Tungsten, uses whole stage of code generation for compact code execution. We will study these kind of concept in later on the session. So it is just I'm explaining how the speed is work for Spark. Spark store intermediate result, as I said in previous, in memory instead of writing to the disk, which limit disk input and output operation and boost the performance of your programs. The next part is usability. So when it terms about usability means Spark provide a simplified programming model, which is very important part. At the API core is a data structure which we call RDD, which is very important parts. So it's a kind of the data sets which called resilient distributed data sets, upon which a higher abstraction are built. So this is RDD is very important parts. And then modularity. Spark support execution all kind of workload written in support language ranging from batch processing to stream processing under a single execution engine. This feature characterizes Spark is a unified big data processing engine. So same Spark, it supports real time and batch, which is very important parts. Next part is extensibility. Unlike Hadoop, Spark decouple store and computation. Spark focus on the fast parallel computation engine rather than storage. It can read from variety of data source. For example, it can read data from HDFS, it can read data from Hive, it can read data from Cassandra. So these are databases, these are storage. It can read data from MongoDB, it can read data from MySQL. The number of Spark connectors are maintained by Spark developer community to connect and extract data source or performance. So I will provide this link so you can see there are numerous people are working on this one, numerous are connector. You can go on the details I will provide. Next, Spark differentiation. So Spark is based on the storage. If you see, as I said in previous lecture, it read data from HDFS, Hadoop, Hive, HBase, S3, Cassandra, MySQL, and JSON. Then on top of the Spark core have basically four main libraries: Spark SQL, Spark Streaming, mlib, GraphX, and on top of that we have datasets and ML libs, and then it support the various language: Java, Scala, Python, and R. So Spark now the next part is a Spark differentiation is MapReduce is ideal large scale batch processing jobs, but falls short for other workloads such as streaming, machine learning, and interactive SQL like the queries. Till for that gap, several other projects such as Apache Storm, Apache Impala, Apache Drill, Apache Mahout, Apache Graph came into being, creating a steeping learning curve and increasing complexity with their own configuration and API. Each specialized engine was customized for a specific type of workload. Spark challenged these states by replacing separate batch processing, graph, stream, query engine like Storm, Impala, Drill, and so all this technology they use on things. So Spark come to solve all this problem in the unified this data platform with unified stack component that address diverse workload under a single distribution path. So if you have like 4 5 these like Drill, Apache mounts, it will quite complex your system. So but if you use one system which is Spark and it provide all solution, then people will use the Spark. So the Spark is solution for all those things. Thus the Spark can be throughout unified engine for big data workload processing. The next component of Spark, as I in my previous this diagram, as you see the component, and I'm going to discuss here. Spark is able to process various type of workload, providing component and library that's suitable for each kind of workload. These 4 components of Spark. First is Spark SQL. This model is ideal for workload structured data and RDBMS stable file formats such as CSV, JSON, Parquet, Avro, etc. Once the data has been read in, you can run the SQL query to create a Spark data frame from data written by query. Now the next Spark support is Spark Emlib. Spark ships with library containing most of common used machine learning algorithm to create model with it. The algorithm built on top of data frame, which is higher level API. Spark structure API. So Spark also support the real time, which I said in earlier. Spark support computation on streaming data from sources such as directly you can read from Kafka, Kinesis, HDFS, or cloud storage. The functionality built in atop Spark SQL engine based on the data frame API. Spark views streaming data as new raw data being appended. Every grouping table can be queried by developer like statics table. GraphX. So is Spark allowed to manipulating GraphX such as social network topology graph, connection points, rewards, and throughout the model with unified stack component addressing diverse workload. Thus the Spark can be throughout as a unified engine for big data workload processing. So thank you for watching. Please like and subscribe my channel so I can create valuable videos like this. Thank you.